people. Let me know when you can see me. Let me know. Alright, so let's see. And awesome, PD Codes is hosting the stream. So thank you so much. Alright, let me shut down my browser. And alright. Still technically 2 minutes before I'm supposed to start. So I'll just sit around and hello everybody. Hello Ginger Bill. Hello Captain Craft. Hello Mickle. Captain Craft, I haven't read your thing yet because I just now saw it when I was booting up the stream. Maybe in the maybe in this sort of preamble to the stream, I'll go and scan it real quick and see if I can see what's going on. Let's see, line numbers. Vim is a current editor, and one of its most valuable features for me is line numbers and relative line numbers. Even though this is something already I introduced, I thought I'd the side of the text which is modifiable, colon, buffer size, etc. This would be very useful for things such as line numbers, relative or absolute colors for national buffer for marking a line of code as you please. If you have any tips and tricks on how to accomplish some of this in the meantime, that would be great. Alright, so Captain Craft, I don't have any way that you can get partial line numbers. So let me tell everyone what he was asking for. He is asking for line numbers down the gutter, which in theory isn't hard to get now that I can just sort of arbitrarily move the code around on the screen. I'm planning on basically, step 1, getting code formatting to just be as awesome as possible. I might, so far, virtual whitespace, this is not a promise, but it's a possibility. So, you know what? It's time for the stream to start, so let's just, let me back, we're going to do this a different way. Alright, hello everyone, welcome to the stream. So, what I want to do before I start is I want to announce a quick shift in my plan for how I'm going to space out the new features I announced a few weeks ago. I'm still planning to do Unicode in the very near future, but it turns out that the basic line wrapping stuff that I wanted to do for the normal buffers is going to push me all the way till release time for October. So the next version will be just code wrapping, and I'm going to try to get code wrapping as far as I can. After that, there's going to be probably Unicode right away, but it's not entirely clear that that's what I'll do because there's a few other things I might want to play with in terms of code formatting that I might not get to before the next version. For instance, right now I'm only virtualizing the white space at the sort of leading white space of a line, right? But in theory, all of the spaces between tokens could also be virtualized. And that would allow you to do really neat things like spacing different things out spacing like operators based on precedence. So if you have like, I've got Scratch right here, so let me just show you. It'd be like if you want to have A plus B or A plus B not in parentheses times C. Well, by operator precedence, you might want to put the times closer, and I tend to type the code that way. I put a space between pluses but not between stars, and that's because of the precedence thing. But having it automatically do that, and maybe not have to have like a full space here, but like there's a slightly wider space and then a slightly thinner space or something, would be nice. And then not having to micromanage the spaces myself would be nice. Additionally, other things that might be nice are, say you've got a line that's, got tabs in it after the initial text. That could be, those tabs can be used to denote breaks between columns, and then you can turn your code into sort of a tabular thing, where if you want to have a real table in your code, you literally just put tabs in it to denote different columns, and there's all kinds of cool things you can do with that. So I'm not totally sure what order that's going to come in. I do intend to get Unicode done shortly. It's just going to be a while. It depends on whether or not I think changing from the current formatting stuff to Unicode will cost me too much versus just keep doing more formatting stuff. Because if I switch off formatting, I get the disadvantage that when I switch back to it, I have to like remember how certain things work again. The flip side of that, though, is if I wait too long to get Unicode in, there's certain parts of the system that care about how Unicode fits in. So I'm just trying to feel my way through when I think the timing on that needs to be. But anyway, that's just a quick announcement. Now, I was answering a question for Captain Kraft. He's asking me about line numbers and stuff, and once all that stuff is done, the code formatting and the Unicode, there's another thing that actually follows very easily from the code formatting stuff, but it doesn't need to come in any particular order, so it'll come later, and that is basically virtual text. I'm virtualizing whitespace right now, but if we go a step further and virtualize text, then we can do all kinds of awesome things. Like the most basic thing would be you could run line numbers through that system. Which is, in general, the idea of virtual text is being able to render characters onto the screen that aren't actually there. That might sound odd, but there's actually a lot of reasons you could want to do that. Obviously, line numbers are one thing, but another thing that would be really great is to take, like, when you're jumping to errors, instead of having the error buffer open, like the compilation buffer open with the list of errors, it'd be great to just jump to the location and then put virtual text under the line that is the compilation error, right? So that would be virtual text, and the system I've got now doesn't really support that, but it's moved me much closer to that than I was before I started the system. So at any point that I want to, I might add that. So that will answer your question, Captain Kraft, that line numbers and stuff, although line numbers could be hacked in an easier way sooner, the general thing of being able to put text in arbitrary locations around your buffer is not too far off in the distance either. To answer the rest of Captain Kraft's question before the stream continues, you can do a relative line number thing, because there's a go-to line, and you can easily get the current line and then plus or minus a certain amount from that to make local jumps, but you're going to have to do that visually without actually seeing which line you think, like, you won't. I know in Vim, at least some versions of Vim that I've seen, if you want to jump up 5 lines, it shows you where -5 is on the relative line thing. You won't have that, but you can still make a relative line jump if you think you can use that without the display. All right, so today, what am I doing? Well, I'm running right now the wrong version of 4Coder, but I'm about to switch to the right version of 4Coder. And I'm going to do that by running it. I'm going to run it in Visual Studio just because I don't know that it really works. I have not seen any crashes with it actually, which is kind of surprising. Like I've had very few crash-related issues as I've been working on this, which is maybe a good sign. But let's see. There we go. Let me just check, since I know full screen is sometimes finicky. I think you guys can see that. Okay. Alright, let's see. So what I want to do today is I've done a little bit of setup on a wave function collapse thing. Now a wave function collapse, if you saw my old tree generation stuff, you will know, uh-oh, what happened? This is odd. I've never seen this before. Alright, so we've got a 4-coder bug, it looks like. It's trying to draw a file. It's... Oh, we're in a loop. Okay, I see what's going on. So my index is 1399. Interesting. So, token array. Tell me what you know about this. Count of 335. So let's look at the 334th index. Or 335th index, but index number 334. It starts at 1399. Tokenize less than count. What if index is greater than or equal to start? I see. So the problem is what then? Size of 1. Well, I see that the problem is that it's iterated the token index past its legal bound. Okay, I get it. I get it. So I just, obviously. Okay. So now, this is why I had the original 4-coder up, was in case I needed to switch to it, but I closed it, because I don't really want to have 2 up. So, you know, I'm conflicted on whether or not to have 2 up. But the problem is that I screwed this up and didn't type it correctly. So I'm saying that index needs to be greater than or equal to the start of the token I'm on to continue looping. But I also want to say that the ++ token I can pop up here, and the token I needs to be less than the token array count. Alright, so I just never triggered that because I don't know, been lucky. Let's try this again. And, you know, I'll pick a different color theme. Yeah, no. I wanted to distinguish between these, but I don't know. I'm too used to this one. Okay, so let's try this again. I pull open WFC, and if you saw my original streams, I was doing a tree generator. Not sure what that was. That's odd. We're not even in virtual whitespace mode right now. I've got, if I turn on whitespace, you can see that I've got all the whitespace. I was generating a tree, and I've not got that project anymore. No, I still have that project. I just don't want to work on that anymore. I mean, I've lost interest. I got about as far down that path as I was interested to go, and I would need to start a completely different path to do good trees from now on. I think I've got a different idea of how I would do that if I was going to do it again. But recently, all over Twitter and the internets, there was wave function collapsing, which looked really interesting. And I want to play with that. I want to see if I can make something that does something kind of like that algorithm, see if I can make a C version. So, here I've got my little experiment set up, and I'm going to work on it. But before we do that, I want to switch to virtual whitespace node. So first of all, I'm going to activate virtual whitespace. There we go. And so now we can already see a few issues cropped up. For instance, comments don't format correctly because they don't really know that it doesn't know that comments need to be indented based on like their alignment or anything like that yet. But you can see all the space that leads the lines is gone except for if the line is blank. Then it just has the new line there. And I'll hide the white space again, and we'll see if I can write some code this way. Oh, uh-oh. Ah, so that's where it went wrong earlier, is that there was no space past, so the size of the file was equal to the, okay, so I'll have to test that later. Apparently if I have a token that ends right at the end of the file, that causes issues. I'm not sure. Alright, so what I've done so far is I've made a little test sample thing. The test samples are 2x2 samples. Each sample has 2 zeros and 2 ones, and I've got every combination of that that's symmetrical. Actually, I just have every possible combination of that. 2 zeros and 2 ones for each block. So like right here you can see I've got 0, 1 on the top row. These kind of, the way they're supposed to line up won't work because they're inside braces, which means that if I want to do this I need like a table thing, but this layout here looks like it's working fine. I could do it this way, right? Then it would work. So the point is, and if I really want it to be symmetrical I would do that, but I just want to show you what it's supposed to look like. So 0, 1, 1, 0, right? And then again 1, 0, 0, 1, and these are 2 of the samples. So that's a black pixel and a white pixel and a black pixel. Sorry, that's a white pixel and a black pixel and a white pixel. Similarly, black, white, white. And I have every combination in this sample set for 2 blacks and 2 whites in a 2x2 grid. Alright, there we go. And I've also got a thing that counts how many, like, it's basically called, I don't know, like a weight for each of those samples, and I've given them all the same weight for now. Then what I did, I stubbed out all these functions. The first system is for listing out the entire wave, right? So this basically, or I guess the samples that the wave is based on. Then to actually run the collapse, you have to provide an output buffer and a state, and then you can just give that, give that state. You know what I should do is just, no, I think this way's out. So what I haven't done yet is I haven't actually implemented any of these stubbed functions, and I haven't gone and learned like where there's going to be issues in the API that require me to like give memory that it needs access to and stuff like that. And then right here it's just outputting the result. But as you can see, it won't build. And it won't build because I haven't defined any of these things, I've just stubbed them out. So, wave 2D function samples, alright. What does that need? Well, I don't know what members that needs necessarily, but I know it needs to be able to do like wave 2D begin samples, wave 2D function samples, and this would be like width, height. So there we go. Let's see, I want to be able to add a sample. And that is static void wave 2D adds sample. I don't like that. So I'll have to think about this issue about unclosed, unmatched braces and parentheses perhaps will be a little trickier than I was initially hoping. the test samples. Now I believe my test samples are uints. Yes, they are. So I take uint 32. This is just the sample, and then I have a little float here called the weight. After that, let me turn on line wrapping too, because that's a part of this whole thing. Wave 2D end samples. Wave 2D function sample. Keep typing that in wrong. Function samples. Boop. Okay. Now you don't like that being empty, which is reasonable. So I'll give you a width and a height. Now an interesting thought is I often like when I'm flowing these things to group them sort of semantically. I don't see any way that that can be done here. Like, it's just going to have to be the case that you deal with the fact that it doesn't group semantically, because you would need some way to infer, like, I could make heuristics like a W and an H if two parameters would differ by W and H, or with the words width and height and stuff like that, but, you know, beyond a certain point, you're just going to have to deal with the fact that it doesn't lay things out in semantic groups, really, unless you manually go and flow it anyway. Yeah. Alright, so here we set the samples width to W and the samples height to H. So Mikkel's asking how the code formatting, code styling stuff will be customizable. And in the first version, it's going to be entirely locked in. The only thing you'll be able to do is pass in parameters for the wrap rules and the indent rules. In future versions, I think what will eventually happen is there will be a low-level way. I'm not sure what will happen. I'm still experimenting with it as I go, but it looks to me like eventually it'll just be C code customization. Basically like everything else, and so it'll be kind of difficult to do your customization at that low level, because you'll have to like write the algorithm that does the indent rule directly, and it sort of generates an array full of where to do each indentation and where to do each wrap. Whenever it asks you, hey, I need new wrapping information for this section of code, you just have to do that, right? You have to have a function that can answer that question in this range, redo the indentation and wrapping rules. I don't see any other way to make that fully customizable, but then to just have the user generate that array and give it to the program. So that's probably where it'll eventually go, but we'll see. I'm still sort of, even though I've got a flexible version of the structure, how it will boil down is still unclear in certain places. Okay, so now what I want to be able to do is add samples. I don't know how at the front end how many samples there's going to be, which means I kind of want to dynamically. Right, so what I probably want to do is just upfront give some memory to the system and let it allocate that as it goes, because I kind of would like to see if that works. So something like wave 2D samples memory, and that's just going to be samples and then sample memory size, 32 sample memory size equals, let's give it let's give it like 64K in this version. Sample memory equals malloc sample memory size. There we go. Let's see. Yeah, so now what'll happen is I'll just pass that in right here. Wave 2D sample memory. Wave 2D function samples. I keep doing waved 2D. Wave 2D function samples. Memory size. And so, you know, I was saying I don't like it, but it could be that I just leave that in, the thing where it indents stuff all crazy weird when you put in an open brace or an open parenthesis, because even though it's a little unusual, it's like a perpetual reminder that you need you're in a certain mode and you need to close that mode to get your code back to balance, right? Because I always sort of in my head maintain that information about whether or not I'm done balancing out the braces or something. And I kind of like the concept that there's a state there that kind of more explicitly shows whether or not you're done balancing it out. I'm not sure. Okay, so now what I'm doing here is I'm basically making a sort of, I don't know what I'll call this, sort of, normally I call it a partition. Whoops, I didn't mean to do that. Partition. That's just because I have a key binding for doing this is right next to the key binding for closing a panel. That's what just happened. It's been bugging me recently because I accidentally do that once in a while. And I'm going to make this actually like a uint8 for the data, and then we'll have a position and we'll have a max. So this will just be a way of handling memory. And this guy here will have his own little partition. And part data equals uint8t data part dot position equals, well, that's already 0 max, right? Guess I don't need to do it that way. Let me do it the new way. Boom, boom. Okay. Alright, so I've got that, and then I need the ability to sort of part push on a partition with a current size. If part position plus size is less than part max, part position plus equals size, return result, void result equals 0, result equals part data plus size. Alright, so now I can get a little memory off of it whenever I need to. And the other thing I basically want to be able to do that I don't normally have is sort of the ability to say, look, I'm currently pushing things on here that are going to make an array, and then I'm going to finalize that array later. So it's going to be like begin array, part partition part. So I can tell that I'm beginning an array, and then let's see. So basically what'll happen is right here I'm going to do samples part equals make part make memory size, and then samples oh, not samples. It'd be part begin array, part no samples part, right? So then I begin an array there. Every time I go to add a sample, what I need to do is push item, push struct. I give you a partition and a type. You return me a t pointer made by part push p size of t. So that was kind of cool. And yeah. And then down here what I'll do is I need to introduce a new struct. So this is going to be like the struct wave 2D. Let's rename that to wave 2D samples. Because a wave 2D function sample doesn't make any sense. Okay, wave 2D samples, and then there's going to be wave 2D sample, which is just a single sample, and that will have the data pointer and the weight, right? And then what I do is I come down here. Whenever I go to add a sample, all I'm doing is I'm saying part or push struct onto the samples partition. I want one wave 2D sample, right? And then I want to do samples.sample count plus, and this right here will be the array of samples, I guess. And then I'll have the sample count. Great. So then, when I'm ending the samples, what I need to do is normalize their weights so that they add to 1. Right? Basically, I want the sum of all of the weights to be 1, and I don't want the ratio between the weights to be affected. So, to do that, oh, and the other thing I need to do is right here, I guess, samples, samples equals, Let's change the name of this to current, and then define part begin array as a thing that takes this and a type, returns a type pointer after doing part current on the P. There we go. So now I can just pop up here and do this right here, wave 2D sample, which is the way I want to do it. And then what I need to do is every time I do that, I need to take a wave 2D sample like so, and I need to go sample sample data equals sample. I can't have two samples, so what I need here is this will be called, I don't have that go to end thing figured out yet. So this will be called data, and this will be called weight, right? Alright, then to end the samples, I run a little loop. So count will be the samples sample count. Okay. And I also want to wave 2D sample array equals samples sample array I dot weight gets added into the total. And then no. Yes. And then after a second loop across, I normalize everything by taking that and dividing out the total, right? So the first loop across, I'm totaling up the total weight. The second loop across, I am dividing everything out from the total weight out from everything so that the weight should roughly sum to 1. Okay. So, that's kind of cool. Oh, shit. Okay. So let me do something here. What are you doing to me? Control comma. Should definitely do something. But it's not doing it. You still think that's the special? I'm confused with you right now, forcoder. I need to restart it because it's bound the build panel the wrong way and now it won't undo it. Wave function collapse code wfc.c. Alright, let's take a look. What do we got? I need to enable virtual whitespace again. Alright, and we're off. So alright, so now I have to write the code down here, and that, yeah, so that's working again. That build is like instantaneous. I guess it's because it's a really small file. Yes, we're in C, so I gotta do the long form type defs for the structs, or struct definitions, I should say. Got to do the long form struct definitions. Badoop. Badoop. Right. It doesn't know about standard lib stuff, does it? Can I actually make sure that I include that there? And actually, can I pop up and make sure that I include that down there as well? Alright. So now it wants me to fill out the wave 2D state. And that's fair, because I did tell it that there was such a thing as wave 2D state. So, let's see if we can help it out. So, to run a state, you have to, let's see what's happening here. We need to set the output size. We're going to need to be able to provide memory again. So, state provide memory, or state memory. State. And, let's see, that process there that allocates the memory. Let's do it again for the state. So you're going to get a partition. And then set output size. So we need to tell it the output size so that it can prepare the grid of superpositions. That's static. Wave 2D set output size. You need a wave 2D state and a a width and a height. Let's see. Then we need the ability to generate output. And that looks like this. Wave 2D generate output. Wave 2D state. State uint32. No. Yes, uint32 out. And the nice thing is this state can be reused on multiple outputs if you want, as long as they're all the same dimensions, without having to flush and reallocate the stack. Because once you know the output size, that fixes the entire possible size of the state of the memory the state needs. Okay, so now, are there any issues? You don't like. You want this? Parenthesis to follow wave 2D state. Now, why are you saying that? Oh, because it doesn't say struct, it says type def, huh? State memory. Ah, you need state memory as well. Static void wave 2D state memory. Wave interesting. Okay, anyway, wave 2D state, memory size, and then we need to take line wrapping's not enabled anymore. I knew something was weird. I was thinking line wrapping shouldn't look like this. Okay. So then what I want to do is I want to take I want to take a copy of this setup up here to make the partition. And now, this is where things start to get interesting. So, to actually generate output from what I remember, what we need first is a big array of booleans. Alright, now we could compress that into bits. Alright, we could say that each boolean is just one bit. Obviously that would mean we need less memory. It would also be a lot more work to pull out the booleans we need, unless we do anything like we have to do bit masking and all that stuff to get it to work right. So let's just do it with 1 byte per boolean, okay? And the number of booleans we need is for each cell in the grid, we need 1 boolean per original sample, basically, right? So what I mean is, if I have all these original samples in my samples, which by the way, that means that needs to get passed in here, samples. And we can go ahead and take this, and what I need that I don't have is the ability to hit the end key and go straight to the end of the visible line and not the end of the textual line. Because if I hit end, I don't want to actually go down a line. I just want to go to the end of the visual line, so that's kind of annoying. I might go fix that right now, because that's an item on my for-coder to-do list. But first, let me fill this in. Samples. Okay, so let's go do a quick bit of for-coder stuff. Code include.cpp. Okay, so begin. Actually, let me go to the bindings real quick. What is the home key bound to? Seek beginning of line. Okay, so what I want to do is I want to go to the include, and I want to make a new one that's not quite seek beginning of line, but custom command sig seek beginning of visual line, or something like this. Or technically what I actually want to do is textual line, and then make this the normal one, right? And what I want seek beginning of line to do is get a summary for a view. I want to, and I'm not using virtual whitespace over here in case that's not clear. I don't want it to do something crazy that I'll mess up for-coder code. Buffer summary buffer equals get the buffer, app view buffer ID, access protected, and then I'll get a new position, which is going to be seek, what I get for view set cursor, app view. I guess I don't need the buffer actually, because I'm not going to seek through the text at all. I don't care about the text. Seek, what's the name of the seek here? Buffer, it's in types somewhere. Seek types, there we go. So wrapped xy, seek xy, using the views cursor, using 0 for the x, using the views cursor dot. Okay, so what I need to do is get, do I have a cursor y function here? Like, get y. Okay, we'll just get it then. So y is going to be view.cursor.wrapped y. And I need the docs real quick because I'm jumping around through this all over the place. So let me pull that up. API docs. Alright, so view summary. Unwrapped lines. Okay. So if view.unwrapped lines y equals unwrapped y and that goes right there as well. Alright, and there we go. I need to tell it whether or not to set the preferred x. It should set the preferred x, and there we go. Okay. And then seek beginning. Wait a minute. Bindings, it's seek beginning of line. Okay. Of line. Of line. And of line. And then I just need to make sure that I set it to a preposterously large x that will go past the edge of any screen, so 100,000 pixels to the right. And now F32 doesn't really exist and all that kind of stuff. Function doesn't really take 3 arguments and all that kind of stuff. Do I want it to round down? Yes. Alright, now it can't open it because I'm running forcoder. So this is where I have to shut everything down, switch over to the real forcoder that is not running off of the debugger, build it again, and pop it open over here. Okay, so what we just did was we made, hopefully at least what we did was we made it so that home and end don't go to the end of the textual line by default. They go to the end of the visual line, which is not in fact what they're doing at all. Oh, that's page up and page down. Fair enough. Home, end, turn on line wrapping, and now if I'm up here and I hit end, home, end, alright, perfect. Uh-oh. Home is broken though on a wrapped line. Yeah, that's not right. So what's going wrong there? I'm sitting here and I just say I want to go to the home of the line. It goes one past the home of the line. So that's a bug right in the cursor seeking. Let's go look at the cursor seeking briefly. Cursor seek. So Alright, I'm gonna have to walk through it in the debugger because I'm not sure that there's too many different ways it could be going wrong now that I think about it. So let's go to WFC, code, WFC.C, virtual whitespace, line wrapping, and I'm getting ready to hit the home key. It's gonna happen any second now. I just need to make sure that when it happens, I will catch it. So let me find my command file. It's around here somewhere. Go near the beginning because you're important. Alright. Breakpoint and home. Alright, so now it's caught the command, and I want to go to default include. You're also important. Stay near the beginning, please. Seek beginning of line. Badoop. Alright. And now it's going to come in here. Are the lines unwrapped? No, they're not. So we're using the wrapped Y, which is good. 34. Right? And that's 34, that's 1, 2, yeah, that's 2. That's the third one down, which is times 2 of 17, which is 34. So that's good. So we're seeking for 0, 34, and we are rounding down. And then it comes to... Oh shoot, I skipped through all the good stuff. Alright, well, let's try it again. Default include, beginning of line, home. Now it's going to go to view set cursor, and I need to actually see that code. I can't, like, F10 through it. Alright, there we go. We got an F11 into it. Very good. Compute the cursor. It's going to come down here, and it's going to go, alright, we're beginning to compute the cursor. But we didn't go into the first step there, so we missed potentially what went wrong. Alright, so let's take a look. Next cursor, position 3. What? Okay, that's right, that's the beginning of the line. And unwrapped Y is 17, but we're seeking for 34. Okay, good. So now it's going to come in here and it's going to just start stringifying through all this stuff, and then it's going to do something else, doing some stuff, reading the thing. It's going to pop out here and get some wrap information from the wrap buffer. Do it again. Alright, let's go back in there and see what's happening now. So gets the line shift. Alright, this is where the interesting stuff is about to happen. So it just got the line shift, so there we go. Next cursor position is going to be 72, 71, I guess. Makes sense because we're skipping the first space of the second line to the virtual white space. CH wrapped X is 9. Unwrapped X is, what is the wrapped Y? 34. Okay, so now it's going to come down here, and it's going to look at the type where wrapped Y. So here's my X, my previous X. Here's my Y and my previous Y. And then it's going to go, okay, if Y is greater than or this, which it is, and X is greater than or it is, are we rounding down? We are not. Therefore, this cursor... Oh, okay. I see what I need to do. I need to take a quick break, and when I get back, I will fix this. But here's what I'm going to do. I'm going to leave you guys a hint, and if I can't remember how to fix this when I get back, you can give me the hint to remind me. And the hint is that even though it's rounding down, that's only supposed to apply to the x value, so if the y value is not correct on the prev, I shouldn't use the prev, okay? Okay, I'll be right back. Alright, so I'm back. And I don't need your hint. I remember it. There we go. Alright, now we can continue working on this wave function collapse stuff. Which is why we're all here. Actually, it's not. We're here to test for coder. But, you know, that's sort of like a secret agenda. Wave function collapse code, the wave function collapse.c file, virtual white space, and line wrapping. Now, if I'm hanging out here and I hit home, brilliant. Alright. So now, even though that's one line, the home doesn't take me to the wrapped beginning of the line, which is nice. Okay, onward with the show. So, I need to allocate all the memory for the state. I have the number of cells in the grid right there, so let's get that. Grid cells equals width times height. And I have the total number of superpositions. Or I'll call that the coefficient count, because it's a little more precise. That's the grid cells times, this is like the grid cell count. And this is like, we take that and do times that. And then, if I want that to wrap in a nice way, we can do it that way. I see I don't have it indenting, like partial, like that, which normally you indent if you're in this land. Oh, that's so weird because the text isn't indented at all. Normally, if you're in this land, oh, it's still wrapping it too. Normally, if you're in this land, the way you do that is like this, right? Obviously. But we are not in that land. We're in this land where the way we do it is like this, because I haven't done it yet. It'll have to happen later. Alright, so there's the coefficient count, and so if I have the coefficient count, then I know how many coefficients to allocate. I'm forgetting there's one other thing, there's like log probability array that I need as well, which I feel like could actually go in the sample count. I have to go study up again how that is supposed to work exactly, because I'm forgetting right off the top of my head. I believe, though, that there's some kind of the log of a small number is like negative, right? Like if it's less than 1, you get a negative number. So now that I think about it, the effect of that log is it makes them all negative. The less likely it is, the more negative it is, which I guess means that the total entropy in a system, in one of the cells, is a negative value. I never really understood entropy when I was in physics classes. Like, I understand the story about entropy, what it's supposed to mean, but the units, I never was able to wrap my head around why it has the units it has and what it does. And I'm not sure that this is even that kind of entropy, but anytime I see the word entropy, I always just sort of freak out that I don't totally know what it's talking about. So, first of all, we just need the coefficients. Yeah, Ginger Bill, I understand that it's the measure of order disorder, but how does it measure that? It's what I don't understand. I understand the story behind entropy. I just don't get it. Like, I don't get how it does what they say it does, is what I'm saying. High entropy means more possible configurations. I see. I see. Easy Sai, are you saying that most computation, like what is commutational? I'm not sure if I know what that means. But negative log p. Maybe I should go read the. I'm gonna go read the C# code in a moment and find out what that part of the code was about. But let's see. Here's the coefficient count. I guess I don't have B8, do I? This should be like u int 8t for the coefficients. U int 32 for the coefficient count, u int 32 for the width and height, u int 32 for the sample count. Oh, because probability addition is the same as multiplication? Like, instead of multiplying the properties, add their... I have to think about that. Okay, so I've recorded all of those, and then what I'm going to do is I'm going to allocate an array. So I need the coefficients to equal whatever I get when I push an array, which I don't have the ability to do yet, but will have soon, off of the states partition of type uint8t with an amount of coefficient count. There we go. And then I want to go to push item, push struct, and push array ptc t star part push p size of t times c. Yeah, I really like that parenthesis thing being that way, actually, because then I don't have to sit there and think of, I guess if I had parenthesis matching, I would be able to do it that way, too. You see, Ginger Bill and Easy Side, this is why I like the handmade community, because it's the only place in the world where there are people who know more than I do. It's like everywhere else I go, no one would be able to tell me all these awesome things that I clearly don't know anything about, but you guys can, so it's cool. Alright, so um, so I've allocated that. I need to set it all to 1. So let's do that real quick. Guess that should be uint to match the boundary thing that it's based on. And then I want to do, let's get a coefficients of coefficients I equals 1. Ginger Bill, do you have any suggestions for good ways to learn thermodynamics? Because if I just Google thermodynamics, I'm going to get like high school level, you know, the second law of thermodynamics type nonsense that I'm already familiar with. That drives me crazy because it doesn't actually help me understand what it's actually talking about. So I'd need like something real to read if I was going to spend any time on it. Otherwise, I'd just drive myself crazy. Okay, so well, I've done ideal gas laws when I was in chemistry. I guess I could review that. Alright, so that basically sets me up. I kind of need to go read the code again, because I'm drawing a blank on a few things. Maybe I never read how those arrays were initialized, because I know there's another array of log probabilities then. I'm not sure how it's initialized. How good is my differentiation? I'm really good at differentiation. I can differentiate between calculus and trigonometry. I can differentiate pretty much any real numbered function, and probably any like I can probably do um, complex numbered functions. I would be surprised if I couldn't. I don't know why I wouldn't be able to do complex numbered functions. Anyway, I mean I've studied um, analytical calculus a little bit here and there in my spare time, but I can never really get very good at it. Um, wave function collapse. Alright, so this code here, model CS had this is the actual wave coefficients. This is a part of the algorithm that we'll get to later. Stationary, I don't remember what that does. I think that's the probability of each point, maybe? Sum equals 0. You loop over all the t's, and okay, we're visiting each point, each grid cell, and for each grid cell we're looking over all of the coefficient, all of the states that are not eliminated and adding in the stationary. If that sum is 0, then return false. So that's the case where it reaches a contradiction. Otherwise it gets a random number from here, and then it's going to calculate the okay, so amount equals 1. Then we have exactly one. That means we have exactly one possible state for this cell. Then we're done. If amount equals t, then we have t is the count of all the different samples. So that means every sample is still possible. We have an entropy of log t for some reason. I think that's just because that's the sum of all of the other things. Like if it's like pre-computed for some reason. So this here log sum is the log of the sum of all the stationaries, and then main sum is the sum of the stationary times the log probability, which gets added up there, and then main sum divided by sum, log sum. Man. So the entropy is the log sum, which is the log of the entire sum, minus the this sum here divided by the standard sum. I'm imagining, so I need to track down and figure out if stationary is in fact the probability or what. As well as the log probability. I need to figure out where that gets initialized, because it's apparently not here. This is the awesome thing about this code, is it's all obfuscated. Okay, so here we go. Log probability is initially, yeah, so that's just the log of each stationary, which is good to know. What is the stationary? Does that ever get instantiated? So like a constructor thing? What, I guess I have to go look at one of the concrete models. So yeah, that looks like a constructor. It's inheriting from the model. Okay. Um, so presumably it's going to have to set all the stationaries at some point in here. Oh yeah, this is where I was reading this code and I discovered all this like lambda style nonsense and my eyes rolled back in my head because I couldn't think about it without going into deep meditation. And I realized that I was having the same frustration that I have when I read obtuse mathematics. Okay. So yeah, here he's doing weights, which means he's counting up how many times he sees the same state, because he's doing like rotations automatically, which I'm not doing right now. Alright, here we go. Stationary equals the new double t, which is one for each sample. Stationary equals the weights of w, and then stationaries are doubles, whereas weights are integers. So there must be some spot where he's normalizing the stationaries or something. Or is it just using the unnormalized probabilities or something? The unnormalized frequencies? Is that good enough? Maybe it is. Pattern from index W. Stationary counter equals weights W. Okay, so seems to me like it's not normalizing the stationary values at all, which means I don't need to normalize my weights, because that's the equivalent in my system, I believe. I mean, it's just copying weights from here into here, right? I don't... Well, what's weights W? Oh, because it has them in a funky order. Okay, so yeah, that's the only reason he's got weights is because it's in a different order than the actual samples came in. Okay, okay. So let's go change that. We don't need to normalize this, I guess. Which means we don't need to do anything when we end at this point. And yeah, so we do need to do, let's go back to the model. Whoops, not main, model. run. So the first thing it's doing is pre-computing some logs so that we don't have to do them too often. And then it does this loop where it does okay, so this is the wrong forcoder. Okay, so to generate output, I'm going to just match a very similar pattern here. So we're going to need a log of t. We're going to need a log probability array, which in theory I could get both of these when I set the output size, which would be nice because then I'm going to need the log of sample count. Let's just go ahead and pull that out real quick. So sample count equals that sample count, and then sample count and log probability equals push an array state partition float sample count, and if I go log prob equals state log prob, log prob equals the log f of I guess those are already in floats. The samples I dot weight. There we go. Alright, so, that's only building because this is C and magical things happen with linkage in C. Let's go ahead and include math.h to doubly be sure. Alright, so now I should have the log2 and all those pre-computed the exact same way this other one does, and off we go. Okay, so we've done that. Clear. I believe clear is for it's setting all of the... Okay, so we've done that before when I set the size. But it's saying I should probably, and it's right, I should do that when I'm about to run because I want to make sure every time I run I get the correct setup. Here's a question. 3 tabs. 2 tabs. 2 tabs. Interesting. So just some weird format situation happened there. And then okay. So the changes thing here is about the propagation system, which is like spread out across this whole abstract boundary thing that's gonna make it harder to decode what's happening. But we'll get around to it. See, here's the propagate, and that's where changes actually gets used. But it's K. It's K. Yeah, the next thing we got to do is this for loop here. It's got a limit to the number of steps that it's willing to do, or it'll keep going forever if limit is 0. So what we'll do for now is we'll put it on an unlimited loop, and then we'll just say, look, we got a counter here. So if I ever want to limit this, it's not that far away. Okay, so now it runs an observe step, decides whether to continue, and then propagate. So observe, check, propagate. Propagate. There we go. Now, during the observe step, what does min get used for? I don't remember reading about min. If entropy is greater than 0 and entropy plus noise is less than min. I see. So this is for counting up who has the smallest entropy, because that's what we're trying to find in this whole loop. So what we're doing first is find out who has the smallest entropy. Find smallest entropy. And so the way we're going to do that is we're going to loop over all of those. And now and all of those. It's kind of neat. So for that to work, we need to have the width and the height pulled back out of the state up here. And then, let's see. So here is something we'll do later. The point is that there are certain grid cells you might want to say ignore those, but I want to do something fancier than this. This is just saying, look, ignore grid cells where their window overlaps a certain boundary, and then abstractly define that boundary. What I'd really like to do is just define a general masking system that sort of captures more details than what that does, and doesn't do it have to like call through other stuff, virtual pointers or whatever. Amount and sum. So those are so descriptive that I'm gonna go read what happens to them. Sum and amount. Sum is the count of how many there are, and the total, not entropy, but the total weight that's still available there to possibly become one of the things, right? So what we have is valid sample count, total weight, right? And then we need to do a loop over the samples, sample count plus t. And for each of those, we need to make sure, first of all, that we've got up here the sample count equals state sample count. And I also want the coefficients. And so at each step here, what we're going to do is grab the cell coefficients as a pointer that points into a portion of this array, in particular, x plus y times width times sample count. And I'll space it out like that. So what I should do is have square brackets follow the same rule as parentheses, actually. Let me go back to forcoder, because I never did the to-do that I needed to do there. I never marked it, I mean. So what I did was home end should go to the beginning and end of visual line. We did that. And we're going to add a new one here and then do it. Handle square brackets. Alright, so this should be quick, hopefully. I just need to go to the file view, right? Close that, switch to here, build it again, interesting before, and there we go. Awesome. It definitely seems like a good idea, so I'll leave it that way. And one other thing I should do before we continue this time is go mark on the to-do the one we just did. So square brackets, done. WFC code. Alright. So I take x plus y times the width to get the correct number for which cell I'm in in a straight line, and then I multiply that by the sample count because each cell has sample count bytes assigned to it. So that right here gives me the array of coefficients for this cell. Finally, what I can do is for each of those coefficients, if cell coefficients t, then what we can do is hey, what's that? Yeah, I got one extra brace in there. Neato. Wow, that's so cool. I think that it might seem odd at first, but if you got used to the code sort of jiggling around beneath you and not like freaking out every time it happened, it could be really useful to see that happen every time. Because like just now, I don't know how I ended up with an extra brace in there, closing me one more time than I needed to be closed, but I could tell right away that it had happened. So I don't know. Anyway, if I've got that coefficient, let's go back to so I can get it. Alright, so what we need is a quick float pointer weights equals samples weights. Weight total equals the weights plus, or total weight equals the weight of that t there. Okay, so that's neat. I've done that. Now what? Alright, so here it's doing a shortcut. If the sum is 0, we have a problem. We have a contradiction. So how exactly does that get used? So the observe result is not. Okay, so what we want to have here is like go to contradiction, right? If the valid sample count equals 0, oops, then go to contradiction, set failed to true, come up here and we'll set uint32t failed to false. If we get right here, then contradiction, if we failed, then we gotta do this sometime. Okay. Alright, what else do we gotta do? We gotta do, not you. Yes, you. So it randomly gets a little bit of noise, and I assume that's to help randomly select which cell is. Like maybe sometimes it picks something that it wouldn't have picked in the ordering just a little bit. I don't know if that's true or not, because it's a very small amount of noise. But either way, what this means is we probably need the random number generator stuff. And it's good that I have that sitting over here in my old jam code. Random, jam.c, where is it? It's like, it's sitting somewhere in here. Math? Is it in my math code? Is it in my math code? PC. Yeah, here it is. So I'll just grab a copy of that real quick, and we can pop it way up here above everything else where it's kind of not getting confused in with more intricate logic stuff. So that needs to be a type def PCG32 uint64t. Whoops. Yes, okay. I'm just going to rename this to random. Yeah. And that gives me a random R. Why is it called a random R? Let's go down to main. And in the main, I will just create my random number generator, and I need to assign it some initial values, I think. randomly. Like, I need some way to get good seeds, but for now we'll just do that. uint 32. Well, why am I separating this out into a separate step? Let's just pick some seeds here. So let's see, 12 and 17. There we go. Now we got some seeds. What we need is, when we go to generate the output, I need to provide a random number generator. And now, random RNG. There we go. Now I need to come back up here because I have a random number generator, but it's not set up to give me it's not set up to give me floats in ranges and nice stuff like that. Hey, the BMXer, I think, BMXer, something like this. What's up? The mixer, the multi-line editing is an experimental feature. It doesn't quite work properly. Like, it's a little bit broken, so it's only included at the $10 tier. It's weird, like, I put my worst work at the highest tier because that's where it's most experimental, so few people will see it. But it's probably gonna be available in the super layer sooner or later. It's implementable at the super layer either way, but right now, no, it's not at that layer, level, tier, whatever it is. Alright, so here's the result. PCG 32 random RNG. And I need to modulo that to something. I'm gonna take 1,000 places of 1,000 sort of digits of, you know, since it's a floating point number, why don't we take like 1,024 bits of where it's not, it's like, what, that's like 10 or bits of precision. This is the universal sign for precision, I guess, like bit precision. So while I'm at it, how about we do this the right way? Okay. So now down here, when I get the random number generator coming in, I can take it and I can generate some noise, which is what this thing here wants. And the noise is just some small number times, here's the random number generator, and then I'll just multiply that by, I don't know, they did 1 to the negative 6, so like, something like that. Or not 1 to the negative 6, but 10 to the negative 6. There we go. Now what? So, question, dude, why are you generating a random noise? Oh, because you use the noise down here. That's a bit odd. I'm going to change the order in which that happens, because it's a bit odd, I think. So, if the count is exactly 1, we've already checked that the count is not 0. So this is kind of like else if valid sample count equals 1, we're going to do stuff, else if valid sample count equals t, no, sample count, that's what I'm calling it. We're going to do stuff else, right? These are the other cases that are here, and the reason is these two it can do really quickly, and it can do them quickly because of stuff, because of shortcuts, things like this. Okay, so if, all right, in that case the entropy is 0. So here's where we're measuring the actual entropy. I don't totally understand what that means, so I'm just going to follow the formula that's given. So in this case, the entropy is 0. In this case, the entropy is the state's log t. And in this case, the entropy is complicated. We need a main sum, whatever that means, and a sum. Oh, a log sum, which is just what we get when we take the log of the total weight. So that's more like the log weight, and this main sum here, I don't know. This is like the entropy sum or whatever the fuck. I don't know. And then we do a loop with t across all of the thingies. I guess the thought here is why is like he's preventing some extra logs by not doing this work in this case and in this case. So we end up looping across t twice, but we do fewer logs in a lot of cases, maybe? I'm not sure. We'll take a look and actually investigate whether that's true later, I guess, but I'm just getting a correct version down for now. So let me do that to do. Is it really faster this way? I guess the point is to avoid too many logs, but actually even that's not true. So it's like too many array lookups in common short-circuitable cases. Is this actually speeding it up for us? Okay. So, what we do at each of these points is we take the weight times the log probability, the weight of t times... Wait, why aren't these pre-multiplied? When do we use log probability other than in that position right there? Log prob. Yeah, okay, so that's just, I think, wrong. Or, like, not wrong, but dumb. So wrong. It's kind of wrong. What we're going to do is just say that the entropy sum plus equals the weight log weight t by log weight t, I guess, because the stationary t doesn't change anywhere in this code, and this is just the log of the stationary, so it's literally just doing the stationary times its log, which it could compute right here. So Well, let me just check one other thing. I don't think it could be, because, I mean, it'd be kind of the staple of over-spaghettified code in the name of separating concerns if log probability was getting used in here anywhere, but computed somewhere else. Okay. Alright, good. Just double checking. Weight by log weight. Did you see that reflow happen automatically right there? That was awesome. That was the shits. Not the well, the shit. If I say it's the shits, it makes it sound like a. It's not. Forget it. Just forget it. There we go. So now it's taking a weight pointer to the first weight, and then at each step it's increasing that weight pointer to the next weight, and then we are taking the weight by log weight and storing it in that array, which is the same as this array. Bada bing, bada boom. Tip def. More automatic codes flowing. Very good. Now, the only thing that might slow me down because of this auto-wrapping thing is that every time it happens, I have to stop and take a mental break to appreciate how awesome it is, right? I'm not sure if I'm actually going to get any of the mental speed up I'm supposed to get. Coefficient count. That's in the state. Oh, that's right, there is no weights array because I made that one big array. Okay, so I just need to do wave 2D sample array samples, and then down here where I think I'm indexing into the weights, I'm actually indenting into the sample array and then getting the weight out of it. And you know what? Because I've already done this once today, here's the weight putter. And then the weight putter equals the float putter that you get when you cast to a single byte type the original weight putter and then add in the stride, right? And the stride is the thing you get where the size of this thing is how many bytes between each weight. And bada boom. Weight by log weight is a pointer. I'm sorry. 7. Easy side, that is false. The person who has a wider screen does not make any white space changes at all. And that is because, let me show you what happens in reality if everyone uses this, or if only certain people use it, there's no conflict. If certain people use different screen widths, still no conflict, because the white space isn't being edited, it's just being displayed that way, right? There's no actual white space being inserted. So let me show you. Here's virtual white space on, here's virtual white space off, here's line wrapping off. Okay, this is what the text actually literally looks like. Okay? And whenever you save it, you can have everyone in the team saving with a system that indents according to the specified indenting rules so that you never get stupid white space collisions. And yet every person can see the exact amount, type of format they want, whether it's line wrapped or not, certain screen widths, certain indent rules, etc. It's completely separating the actual text from the presentation of the text, which means you can see what you want while saving it in a different format. It's kind of cool. Okay, so weight by log weight. On top of that, once this becomes popular, right? Once everyone's using this, all source code control systems should just ignore white space changes. That should just be optimized right the fuck out of everything. Alright, so log weight is not a member. What are you talking about? It's right there. Weight by log weight. Are you getting it out of samples? Ah. Yeah, easy side, that's right. So there's basically, you have a thing called your auto indenter, which is what, this is not that. The auto indenter just does the formatting of the text according to whatever rule you want your text laid out in. And then this new thing I'm working on is, I don't know what you want to call it, the code flower, the code wrapper, the code presentation engine is probably the best way I can name it, which is completely separated. It looks at the text and figures out how to present it to you in a nice way that is separated from the actual whitespace rules that you've got underneath. So easy side, you're like the fourth person who needs a terminal version, and I'm one of the other three. Another nice thing about this that I totally forgot is I could switch to to proportional again, but I don't like this font. I want to get the input font. I don't know if you've seen input before, but it looks like a coding font, but it's still proportional. I want that, but I don't know, like, I've been asking them about their licensing rules, and they haven't responded yet, but I don't know if I can distribute that font with Forcoder, so I might have to build in, like, full font support someday. Then I can just say, hey, download input for yourself and use it, but I can't distribute it to you, and then we're great, right? But anyway, the nice thing about the proportional fonts is that you can use them and it'll format them correctly, since it doesn't care about how, it doesn't use spaces to do indentation, it just puts the text in the right spot. So the proportional font works, and then it will save it with the assumption that it's monospace fonts, so that it will line things up with spaces or tabs or whatever your convention is. That being said, neither of the systems are super great. A really good like text formatter would be nice for people, but I'm hoping eventually that the format of the text will become irrelevant. But for transitional purposes, it's not a problem anyway. The Bemixer, ask insofar as. He built it in 32-bit at one point, and I assume that it works. I can't build it in 32-bit because I'm not set up to do it. If we took some time to set it up, I could. Yeah, maybe what we'll do is for the next version, I'll have insofar as help me walk me through building it on 32-bit and see if we can distribute a 32-bit version. Because there's no reason we can't, as far as I know. I need a little water soon. Okay, so anyway, yeah, so now what we're doing is we're computing the entropy. We've got the entropy sum, and I went and did the weights by log weight, so we don't have to do the multiply. We don't ever have to do that multiply, which is nice. Where am I? This is not the model. This is one of the derived things. Switch to the model. Okay. So now we're going to take the entropy as the log sum minus the main sum over the sum. Okay, so the entropy equals the log weight minus the entropy sum divided by the total weight. Right. So let's see, this is some big negative number. So this is actually going to be a positive thing that I'm adding to the log weight. The log weight, I want to understand this, so give me a moment. The log weight is the log of the total weight, right? I took the weight of all the, that should be log total weight. I took the total weight of all of the states that are not zeroed out, and I added those weights up. That gave me a total weight. I took the log of that. Now that could be great. That could be negative. Okay, so that could be positive because those weights aren't normalized, so they could be very large, right? Which means that the values I get back could be positive, right? So total weight isn't necessarily a sum that's less than or equal to 1. It could be greater than 1. That could be anywhere between negative infinity and positive infinity. Okay. And then, and the if it has lots of big positive contributions, then it will be very positive. If it has very small contributions, it will be much closer to 0 or negative. And then I take the entropy sum, which I get by each of the log weights times each of the weights, and adding those together. So that is like log weight to the weight, or what's going on there? Add those all up. So if it's a lot of very small weights, for instance, then the total might be close to, like, might be large enough that it's a positive total weight, but the other thing would be negative, which would make the higher entropy. Whereas if it had just one or two, just two, if it has one, it's an entropy of 0, it says. Let me think. The entropy sum. So the entropy does. Okay, this would definitely turn out to be 0 if I only had one thing there, because I would take the log of that, and then this here would be just equal to that, and I would get a 0. That makes perfect sense. Say I have two things, and they're each got a count of 1 on them. Then the total here is 2, so this would give me something that's positive. I feel like they should be normalized. Am I crazy in thinking that they should be normalized? Because then this would be, I don't know. You guys know more about entropy than me. Does this formula look like it makes sense? I'm adding up, I have the sum of a bunch of values times the log of that value, and adding all those up. and then dividing by the sum of the non-logged parts. The non-logged parts are they're all positive. So the only thing that can make this thing here, this whole thing will be positive if, how can it be negative? It can be negative if this thing works out to be negative and this does not work out to be negative. But if this is negative, this should definitely be negative. Bye the BMXer, BMXer. See you later. If this is negative, these have to be negative, and they have to, each one of them would be more negative by a lot. So it would be positive. If this is positive, these would be positive, but they'd be positive. This is like n, and this is n log n, kind of. But this is logged after each one is added up. Whereas these are all logged separately and then summed together. Seems like that could still be negative pretty easily. I don't know. It could be that this is positive and that these are all negative. If I have like 10 1/2s, right? Then this would be a 5, this would be positive, but each of these would be negative, and then this would be very positive. So let me know if that makes sense. I don't know if this formula, if I'm missing something. I don't have a good enough grasp, so I need somebody with other intuitions to pipe in there. So anyway, that's the formula that looks like it's being done here, but I'm not totally sure that it is. Okay, so if the entropy is greater than 0, and the entropy plus the noise is less than the min, then we update the min, and, right. So what they mean to say is something like, if entropy is greater than 0, I think even if it is, why don't we add the noise in anyway? Let's just try something. Entropy plus equals noise. If entropy is less than, you can get a negative entropy pretty easily though. I'm confused. This is saying entropy greater than 0, so maybe this always is positive? Why would this be called log probability? If it's equal to stationary t, then that would be less than 1, which would make it negative. If all of these little things are negative, then this here will be hugely positive. Yeah, it seems like they should be normalized, but I don't see any code. Let me check again, because I feel like they should be normalized. Look around here. Stationary. No. Stationary. New double. Double is the weights, and that's it. That's all of it. Here the weights are just a sum, the count. So that's not normalized by any stretch of the imagination. It's not normalized. Models doesn't do anything to normalize the stationary, does it? No, it doesn't. So yeah, they're definitely not normalizing it in this code, but it seems odd. Okay, anyways, if entropy is less than min, then why would you not store, so here you've got a 0 entropy. If entropy equals 0, you don't want to do this. Argmin x, argmin y. Oh, if you're already down to 1, you don't want to visit this again. Okay, I see, I see. So, let's do it this way. If entropy is greater than 0, then entropy plus equals the noise. If entropy is less than min, min equals entropy, best x equals x, best y equals y, do 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 Alright, so we've got that, more like indentation craziness, actually, and then what we do, as I expected when I set those to be width and height initially, is we check to see if we actually got one, right? So if best width is less than, or if best x is less than width and best y is less than height, we got one. Then what I want to do is I want to add this concept of min entropy, which I don't actually have. Min entropy entropy, and then we'll set it to something like a big number. Hopefully that's big enough. And then if we actually got one, no, if we didn't get one, if this equals width and this equals height, then we got one, right? So then we can go to finished. Contradictions, call that finished. Boom. So if we go to finished and we failed, else if we succeeded, we got to do other stuff, right? And let's invert those. Alright, great. So if we reach this case, then go to finished. Awesome. Now what? One second. Gonna go. And we're back. Alright, so now it creates a new array called the distribution. And the distribution is storing zeros where there's the coefficient of 0, and so this should just be a multiply. I'm not sure why they're not multiplying, because the wave is just storing it's because they've got bools instead of ints, and they can't convert back and forth in this language or something, maybe. But you just multiply the coefficient by the stationary and store that in the corresponding spot there. And then what is that doing? Oh, this is for randomly picking. It randomly gets a floating point value and uses that. Oh, so it's like roll a die where we've set the probability of each face based on this array. That's neat. How do I want to do that? So I've got these weights, and I basically want to get, I've got the total weight, right? So I I roll the die and I scale it to the value between um, between 0 and the total, and then I subtract out that from each one until I find something that's goes less than or equal to 0. And I do the subtract. Okay. Cool enough. So, less than 0 it should be. Okay, so, we have a total weight. Let's get the die roll here. Equals total weight times the PCG32 random float between 0 and 1. Here's the random number generator. Now I've got my die roll. Is my line wrapping on? Okay, it's on. Just doesn't wrap in front of my face. Also, why is the relative scrolling thing broken? The cursor should remain fixed when I do that. I gotta fix that. It's a bug. Alright. Then what we do is we say, look, for int32t, t equals 0, t is less than the sample count, plus plus t, give me a weight pointer, give me a stride, give me an incrementation, die roll minus equals weight putter times cell coefficient t, right? Or it's more like, yeah, this will work. And then, if die roll is less than 0, then hit element equals t. Break. int32t, hit element equals sample count. Then I want to do is say, if hit element equals sample count, failed equals 1, go to finished. Alright, so now I've got a t, a hit element, which is equivalent to this r here. And now what it's doing is it's saying, for everyone in this array, set the coefficient to 0 if t is not r, and 1 if t is r. Fair enough. So that's just a matter of t equals 0, t is less than the sample count, plus the t, the cell coefficients, t, I have to get the right cell coefficients. I haven't got those. Okay, we'll get that soon. Cell coefficients t equals hit element. There we go. Now, I assumed that I had a cell coefficients array, but I don't. And the reason I don't is because the cell coefficients is in this scope here. But I can grab a quick copy of it, and since the code auto wraps, it will figure out if I need to do anything as I fill it out to be best x best y. Apparently doesn't think so, which is kind of cool. And then let's see. Do. Wait a minute. Okay. Okay, so what have we got so far? That should be best Y. Total weight. Oh, I didn't keep the total weight. So total weight gets added up in here, but out here I want like a best total weight, right? And then down here we can just replace this with best total weight everywhere. Okay, great. Now what? Okay, so we're done, which means it now can do an observation, which is good. It can loop across all of the things, and it finds the one with the lowest entropy, and then it randomly decides how to complete that location. It doesn't, after that point, propagate that information to other surrounding cells, which is important, because once I make the decision about what state this cell can be in, that affects the surrounding cells. They now have to change, some of their coefficients need to switch to 0, because they can no longer be in those states. So let's read how that code works a little bit in the C# algorithm that was posted online here. Let's see. Yes. So let's look at the overlapping model. So the propagator is a 4-dimensional array of integers. N is the window size, which they've made the same in... I guess that's so that they can enable rotations more easily. Yeah, I guess so. That's not how I would have thought about it, but okay, that's fine. Let's see. Colors, ground, overlapping model. We set the N. Periodic equals periodic output. By the way, does this implement on boundary equals not periodic and x plus n is greater than fmx or y plus n is right. So that's what I suspected this was doing, although I didn't check. And they've just got this as a variable, which of course makes you wonder why it has to be virtual, but we'll not dig into that. fmx, fmy are the output width and output height. Here's the input bitmap, I assume. This is like some crazy string replacement thing, I guess. Yeah, string name, that's probably getting substituted right there. SMX equals the source bitmap width and height. Okay. We're not doing that, but that's fine. Sample equals, okay, so it's making one sample for each position, and then blah, 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 blah. So it's going across the entire input, getting each pixel out of the bitmap, and using that to create a palette of colors, so assumedly. And then let's see, intent byte array pattern equals the... This is where things get crazy. So they're basically here making the thing that does the reflections and rotations automatically. And I really don't want to read that again. It's Just don't do this. This is crazy. I don't like it. So this equals result equals 0, power equals 1 for int I equals 0, I is less than p dot length. So you're reverse iterating through an array, although you didn't set I equal to length and then I greater than or equal to 0 or anything like that, which would have been, you know, better, but okay, that's fine. We'll read it this way. Length minus 1 minus I gives me a value times power. Add that to the result, and power times equals C. What the hell is C? Colors? The number of colors. You're figuring out how to, this is, okay, you're using this to index into something. Wow, okay, so P is like a variable length. Is this like supposed to be dimension agnostic, or what's the deal here? So P is some length, no, some array. We're iterating across the values. They're presumably integers because we're multiplying them by integers and adding them to an integer. So this is an integer times the power. Okay, so this is doing it's packing okay, so it's taking an array of colors and making a single index for that array of colors. Okay, I get what it's doing. To repeat this, P is an array of colors. The missing type information makes that very opaque, but that's what it is. For each of those colors, we've got a thing that maps basically that color to a specific index? No. Yeah? P. Actually, what is the array P? We're making an index. Okay, so P is like it's not an array of colors, it's an array of indexes which index into an array of colors, and the indices range from 0 to C minus 1. Okay? And the point is that the result is some number in base C, which is basically saying it's a clever way of taking the samples and giving each one an index, or a hash, if you will, and making it so that those hashes are unique for each, no matter what, for all the possible palettes, which might conceivably be useful if you're trying to count how many times does this particular sample occur given an image, which is what they're doing. Here they put in an index, they use that to let's see, power equals W. Don't know what W means. Ah, that's C to the n squared. I see. So that's the reverse direction. I see. So it's using an index to build back out the palette. Question time. Say I've got 4 colors in a 9 by 9 palette. That's 4 to the 9, right? Okay. So that fits in an integer. Let's suppose I have just, I don't know, 20 colors in a 3 by 3 palette. Okay. Ten to the 9 wouldn't work, would it? I don't think that fits in an integer. 1,000. Okay, that fits in an integer. So you could do 3 by 3 palettes. What about if I had like 5 things only in a 4 by 4 palette? All right, so that's why they stick to 3 by 3 right there. Um, all right, good to know. Let's see. Weights, new dictionary, int, list, int, ordering, new list, int, blah, blah, blah. Periodic input. They're doing their little, oh, that's doubly indented because it's a double for loop. I see. I see. So if int y equals 0, y is less than periodic input, blah, blah, blah. Otherwise, y is less than periodic input question mark. If the input is periodic, we go all the way to SMY, otherwise we stop at that point. Gotcha. And then we use all these things to create all the possible patterns, and store them in what, like an 8 by undefined byte array, like a 2-dimensional byte array, and then we use each of those. We get an index from each of those to put there. Why are we storing? Oh, we have to store. Why? Yeah, we shouldn't be storing the PS. We should just be like reflecting it and then passing it in here, and then rotating it and passing it in here. I guess they were concerned about duplicating this code, but then or trying to loop over something that changed like this. Yeah, I feel like. Oh, plus there's like concerns about chaining one to the next, I guess. So you need 6 to build this one, and 4 to build this one, and 2 to build this one. Alright, I see why they set it up this way. I see. T is the total number of weights, apparently, which means it's the number of samples. Ground is ground plus T modulo T. I'm not sure what ground means. Is it like a negative number? Or yeah, what does ground do? I guess they're using that to force a few pixels in place in certain bitmaps where they have like a ground here. Which means they didn't generate the ground the way I thought they did, maybe. So it literally just means the ground that they're trying to force it to generate. Okie doke. Got it. Patterns equals, we have T of them, and each is an array of bytes. Why weren't we storing them while we generated them? I guess because we don't know. I don't know. I guess we don't know how many patterns we've got until this is done. So the propagator is this 4-dimensional thing, which we saw up here. We're finally getting to. It's indeterminate in these 3 dimensions, apparently, and 2 times n minus 1 in that dimension. We'll find out what that means soon enough. Counter equals 0. For each integer in the ordering. The ordering is the order that the samples show up in out of order, I think. Or, not the samples, the colors, maybe? No, definitely the samples. Yeah. Why would you need them to be in a specific order, actually? Oh, I guess the indices... Okay, so the indices don't come in sequential order, so we're making an order of the indices because the indices are not sequential. So this is sequential, this is non-sequential, that's a mapping. Got it. So pattern from index W, we get the patterns. we store in there one of the patterns. Got it. Here, stationary counter equals the weight of this one. All right. So this is the part that I'm like hard coded into my code right now. The wave has a fixed equal to the width, and changes equal to the width, and then wave x equals. Okay, so they're fixing all of the thing to be fmx by fmy, which means this width of the output times this height of the output, which is fine. Not sure what wave is. I don't think I've seen that before. Each of those. Oh, wave is the coefficients. That's right. And this here is the changes array. They're clearing that to 0 and clearing that to 1. They're also going to clear that every time they run it, so they're clearing it twice. Awesome. Agrees. dx dy. If dx is less than 0, then 0, otherwise dx. X min, if dx is less than 0, then dx plus n, otherwise n. We're picking for y equals y min to y max, for x equals x min to x max, p1 x plus n times y does not equal p2 x minus dx plus n times y minus dy. Return false. So you're going to loop across a bunch of things. If any of them disagree, I see. So you're taking two bitmaps at different positions. No, at one position agrees. P1, P2. X plus N. I see. So P1 you're indexing directly. P2 you've shifted some other location. And you're taking a look at both of those and saying, do they disagree on any of their overlapping points? Okay, got it. Which you're going to need for doing propagation. Alright, and x equals 0, x is less than 2 times n minus 1, so that's less than the double width. In the range of the double width, we increment x. Propagator x equals... Okay, a propagator is four-dimensional. It's got twice the width, twice the height, an array of samples, and then each of those array of samples you allocate a list. If pattern T agrees with pattern T2, you add T2 to that list. Oh, wow. Okay, so they're allocating a big ol' array, and at each point in that array, it's basically a big, gigantic four-dimensional matrix that keeps track of which samples can overlap with which samples at which positions. Okay. Let me think about that. if you have n samples and if you have m, let's say we have t samples and they're each n by n, then you need 2 times n minus 1 locations to overlap them. Because if it's 2n, then you can fit them in the corners where they don't overlap. But if it's 2n minus 1, then they are always overlapping by at least 1 pixel. And then you can say, are they equal? Like the one is in the top left corner and it's fixed there, and the other one is shifted by 1, 2, 3, 1, 2, 3, 1, 2, but then if it goes past, say my n is 4, so I can shift it 0, 1, 2, 3, they're still overlapping. If I shift it by 4, then I want these two to be overlapping in that to have the meaning that these two are overlapping here, right? So why would I need that? 1, 2, 3, 4. I don't feel like I understand. We're overlapping, going through all the samples, and then going through all the samples again. For each pair of samples, we put one in the left corner. We put the other one... No, we put one right in the center, and we put the other one in every possible location like this. But then you're gonna eventually flip it and put T1 here and do the same thing. I feel like that's I think that's doing twice as much work as it needs to. The advantage of this setup is once you know your T1, you can find your T2, your relationship to, if you have any two samples and you know where one is, you don't need to check and see which one's bigger than the other one. But if you wanted to, you could store half as much information by saying that the sample with the smaller index always gets positioned basically in the center. Or what you could do is you make it an n by n grid instead of a 2n minus 1 by 2n minus 1 grid. Or an n minus 1 grid, actually. So if I have 4, I take 3 different sample locations. This one, this one, this one, and this one. And then later on I will put this one on the left and take this one, this one, this one, and this one. And I already know that 0, 0 never lines up. So that's just there so that all the memory lines up easily, I guess. But I can easily say, look, if they're overlapped with each other, then those two samples, you never need to check if two samples overlap with one another, basically. So what we'll do is we'll say that you don't need to care about, but the other cases, whichever one is farther to the right, comes second in the order. So we test there, 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 and there. There, 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 and there. I guess that doesn't give you shifts like this. So you need to test everywhere to the right. So you need a width of n minus 1 by 2n minus 1 to do it my way. But because you still need to do like the y's here, here, and here, and here, here, and here, and all those with the various amounts of x alignment. But you don't need to do what this is doing. Now the other thing they're doing is, once they've done this, they make a list for each one. So instead of doing what I'm thinking, which is you make a matrix of agreement and disagreement, what they actually have is a list, which means every time they want to see if two things agree, they don't just look it up. They go to that spot and say, do these agree at this position or not? The advantage here is probably very few of them agree sometimes, so you have large blocks of 0, and that maybe saves some space, but the disadvantage is that it's going to take a loop every time you want to check if two things can coexist, and then you have to do the overspecified thing where it exists in both spots. Unless you switch back to my other plan where the smaller one is always the one that contains the bigger one in its list. Okay, fair enough. I'll deal with that when I get to it. I've got the idea. Um, in theory, I might not even want to do this as a lookup table right away. I might lay off on this concept. I mean, we'll see how often it gets used down here um, before I make a determination. Okay, so the propagate step, it looks at um, every position on the grid and asks if there are changes. Okay, if there are changes, then what it does is it indents this a bunch of times, and then it sets that to false, and then what it does is it loops over all of the overlapping neighbors and says, look, if x2 is less than 0, x2 plus equals fmx, else if x2 is greater than or equal to 0, x2 minus equals fmx. Yeah, it's looking for the neighboring cells that it overlaps with. Just makes sense. Yes. It's skipping ones where it's not on the border, which, interestingly, they don't call the on the border function for this one. I'm not sure what's going on there, but okay. Then the bool w1, w2. So we take the two positions that we're looking at, x1 and position 1 and position 2. We take their coefficients. And for each of those, we take a slice out of the propagator, like we take the portion in the propagator where, where the dx and dy have these particular values, right? And that means what we have here is a two-dimensional array that came out of the propagator array. And this two-dimensional array tells us the relationship between the things in W1 that are still like possible states, and the things in W2 that are still possible states. And so then what we do is T2 equals 0, T2 is less than T. We iterate over, where do we have a T2? Where's T1? T1, T1, T1. Don't see it. Oh well. We'll look at everything in wave 2 and see if it's still a possible sample. If it is a possible sample, we set b equals false. And then we look to see if any of them if b equals w. So we take I1 equals 0 to propagation prop length. What is prop? Prop is, I see, so we've already plugged in T2 to the P, and that spit out an array called prop, and that gives us all the spots where T2 might I see. So now we're looking to see, does anything in W, we plug I1 into prop. Right, okay, so the concept is look through everything in, basically find a state in W1, or, okay, it's two waves, right, that overlap. They're possibly one or more, both of them are not completely determined. And it's saying, look at all of the undetermined parts of wave 2, or look at all the possible values to put in cell 2. Look at where that, look at its like conflict list, and then loop over its conflict list for each thing in its conflict list. And that's why they're not doing a lookup matrix. They're doing this because they need to look over all the possible conflict positions or agreement positions, I'm not sure, and say w1 if not b, changes x2 y2 is true, change equals true, wt okay, this seems really odd because that means you could potentially I'm not sure I understand. I guess this works because every time you do this, it doesn't matter what order you're doing it in, kind of. Maybe you're just trying to deal with find all of the conflicting points and eliminate them. So B is false. If we get all the way through and B is still false, then we change it. But if B agrees with any of the existing things, WT T2 equals false. I see. So we are saying, does this state disagree with every possible value for W1? So basically what we have is two waves. We're looking across everything in wave 2 and saying, does anything in this wave cell value disagree with every possibility in the overlapping W1? If it disagrees with everything, then that value needs to be taken out. We keep on doing that until we can't anymore make any changes by propagation. Then we do another observation. I see. Okay, we can do this. So, let's implement propagate first and let it be slow, and then maybe next time I will speed it up. How much time do I have? Oh man, it's been about 3 hours. Let's do a little bit of the propagate, and then I'll do this again next week. No, not this function. Where's the propagate function? There it is. So propagate, in order to propagate, I just need to loop over everything. Same way I did earlier in this observation stage. And I need to add each of those points. I need to know where changes have happened. So I don't have that array yet, but I'll get it. So changes x plus y times width. Why is changes in a grid-shaped array? Why don't I make changes a queue? Because then what we could do is say for int 32 I equals 0, I is less than change count plus plus I. Wave 2D change change equals changes I. Right? And then that'll happen implicitly. We then do the loop over the neighbors. So this is where we go, look, int 32 x2 equals negative width plus 1. No, I need like sample width. Where's my sample width? Does anyone know where my sample width is? Samples. Okay, samples does have the width and height. So let's just store that real quick. Sample width equals samples W. W becomes H. So samples width, sample width, come on, plus 1. X2 is less than sample width, plus plus x2. Same thing again with y's. width becomes height, x2 becomes y2. Alright, so that avoids a like 4-level loop with an if in the middle, which is kind of nice, and is going to have another 2 loops inside of it. So we got one less loop in there now, and that loop's gonna have a lot fewer hits, I think, like a lot fewer misses. We're skipping over a lot of misses now. Okay, so now we have, and since they had like all these lists and everything, I'm not sure why they didn't take advantage of that, but okay. So, like, we're pre-caching logs, but we're not doing this as a queue. Really? That's odd. It's odd. So we loop over all the neighbors, and we find we gotta clamp it to okay, so they're actually calling that dx and dy, which makes sense. That's the difference between the current x and the new x. So dx dy, and then we get uint32x2 equals change.x plus dx. Guess that should be an int32 or it'll freak out. y2 equals change.y plus dy. Then we got to deal with the clamping, or the wrapping, which is kind of odd. They're not just doing a modulus here, isn't it? Let's just do this is width modulo width plus height modulo height. Ignoring the periodic stuff. Alright, so we want to get the coefficients for both of the waves that we're talking about. So we need uint 8t cell 1 equals coefficients change.x plus change.y times width, and x2, y2. Alright, now what do we do? It wants me to index into the propagator array, but I don't have that yet. We're gonna have to evaluate the propagator values manually, which means we're walking around. We know about the dx and the dy, so we just have to use that to figure out how these two things are relatively located and compare them. And then later we will probably tabularize that somehow. Yeah. Alright, so for now let's do it this way. For int32t equals 0, t is less than the sample count, plus the t. If cell1 if cell2 t then uint 32t b, great name, can coexist equals 0 for, and now it's doing a loop over all of the I1. That's all of the points that are known to be coexisting, but I'm going to do T2 here. This is probably why their variable is T2 now that I think about it. They probably wrote it this way to begin with. And then got rid of the T1 at some point. So T1 equals 0. T1 is less than the sample count plus the T1. If they can coexist, we eventually find out whether or not they can. If they cannot coexist, then what we do is, first of all, cell2 T2 gets set to 0. So the point is, cell 1 was the one we got from an existing change. We're not trying to change things about this. We're trying to propagate this change to surrounding neighbor cells. Let's see, the second cell can be changed because it is the neighboring cell, right? But I want to have a thing outside of this loop that says b30, or I don't have b's, but uint32 cell2 changed equals 0. If this happens, I'm going to set cell2 changed equal 1, and then out the other end, if cell2 changed, then what I want to do is then I want to do changes change count plus equals new change wave 2D change equals changes wave 2D new change dot x equals x2, new change dot y equals y2, and then it'll get processed in a future step. So I see Strange Zach is in the chat and he's got a question. He asked me, what does the keyword override mean? I don't know for sure because I don't program in C#, but I assume that that's because these are abstract in the base class. So that is there to tell it that it somehow needs to be specified that it's overriding that abstract function from the base class. Okay, so if they cannot coexist, we do blah, cell2 change, blah, blah, blah. And then, here what we need to do is check and see if the two cells can coexist. So, the way this works, coexist check. We've got the dx, dy, which, basically x1 is at a known position, x2 position 1 is here, and x1 x2 y2 are these offsets from there. We're just going to assume for now that it's the dx dy that we need to care about, not the x2, y2, y1, x1, y1 stuff, right? And what I do is I need to get the two samples. So basically I need uint32 sample1 equals the samples samples.t1.data, and this is sample2 t2, and then what I need to do is I need to discover the amount of overlapping positions between them. So the amount of overlap, we'll only index, well, we have to index into both, but yeah, so the min x that we care about is 0 or okay, I see. So uint32t min x equals 0, max x equals sample width, min y equals 0, max y equals sample height. If min x is less than dx, then min x equals dx. If max x is greater than, what is it? Dx plus sample width, then max x equals the dx plus sample width. Right? So the point is just I took the original box that exactly matches sample 1's coordinates, which is 0 to sample width, 0 to sample height, and then I'm saying, look, if the min x is too small, we'll know because the dx will position the other one over here, so then we'll squeeze that out. And same thing with max x. If it's shifted over here, then the sample width plus the dx will be less than the max x, and that's as far as we need to go, right? Same thing with the y's. This one doesn't quite work, but there we go, now it works. And I need to turn that into a height. Okay. We're almost done. Okay, so now what I need to do is loop over the ranges I've got here and check and see 32t sx equals min x, sx is less than max x, plus plus xx. For uint32 dy, sy equals min y, sy is less than max y, plus plus sy. Then what we need to do is if sample1 dot sx plus sy times sample width does not equal sample2 sx plus dx. No. Yes? Minus dx, right? No. min x is not less than dx. Yeah, minus dx, right? Plus sy minus dy times sample height. Ooh, that's no good. Let's condense these subtractions like that. There we go. Alright. Then can coexist. So what I need to do here is I need to make sure that I only do this if cell 1 T1 is true. So yeah, if cell 1 T1, then I want to see if these two things overlap. And coexist check result equals 1. If those are not equal, then the coexist check is 0, and we can go to finish coexist check. Right? And that should technically take me right here if I'm going to pull this out into a function later. And then if not coexist check result, then we can break out of the loop. You know what, I can't, I'll have to. This is eventually going to get rewritten a little bit, so this kind of doesn't look the way it would if I was writing the final version of this, but it's not worth it. So, T1 equals 0, T1 sample count, we check all the T1s, any of them that actually exist in cell 1, we check if they can coexist with everything in, with the thing we're checking in cell 2. If it cannot, then we set that to 0 and we're done, and then we break out of here. But not before we set the can coexist to 0, and then it breaks out of that for loop, and then it yeah, and then it finally can come down here and go, aha, cell 2 did change in at least one way, and so add it to the queue next time. Alright, awesome. So this is not totally done. Obviously the change queue here doesn't exist. So I've got to do that at some point, and on top of that, maybe other things. I need to record. In particular, I need to record this. When I've done this, I need to record changes, change count plus plus, equals new change, where new change in this case means wave 2D change, new change, new change. Whoops. What I meant to say was new change dot xy equals best xy, right? Changes, change count, blah blah blah. Right, so then the only thing left for me to do now is the changes don't actually exist. That all this changes stuff doesn't actually exist anywhere in the code, which is fine. I'll just go ahead and squeeze that in here at the last few minutes. Type def struct wave 2D change. Wave 2D change is just an int32 xy pair. Now best x, best y are probably unsigned. I'm going to try to make this unsigned. It's going to complain at me because I have to use signed integers at one point for the dx dy there, and then but they're always unsigned by the time they come out the other end. So why don't we just do that, and there we go. Changes doesn't exist. Right. So let's see if we can get that array now. Up here at the top, why don't we say that you've got to provide it some scratch memory. And then we'll use that to create a partition right here. Part make scratch size, and then actually we don't need to do that. That's dumb. What we want to do is just say, look, wave 2D changes. Well, we might eventually want other things. So what I'm going to do is say, there we go, and then wave 2D change equals, or changes equals part array, part begin array. Here is the part, here is the type. And then or we can go a step farther and go like change max equals 1000 or something. Or why don't we make this just equal to change max equals, I don't know how I want to do this. I know I need a change count, which equals 0, and then begin array. Alright, just screw it. Wave 2D change array from the scratch int32 change max equals scratch size over size of wave 2D change. Alright, so then what all I have to do now is every time I'm done with this big loop here, change count goes back to 0, and if I find at any point that change count equals change max, before I add a change, what I'll do is I'll say if what is the iterator here? I. I'm not using I anywhere else. Looks like I avoided it. Okay, so what we'll do is we'll just mem move everything from changes, everything into changes from changes plus I plus 1, because we've just consumed that change, and the amount we need is change count minus I minus 1, I suspect, minus I plus 1, or I plus 1 rather. Yeah. Change count minus equals n, I equals 0, negative 1, and then you've got more space. If oh, but every time we do this, we don't necessarily know that we've... Okay. We don't necessarily know that we've finished with that change already. Right. Okay. So that's built. I haven't run it at any point along this entire way. So let's go over to my project real quick and see if this version runs. Alright, so it ran without crashing. Obviously it didn't do anything good. It's all bad, everything bad. is what happened. Let me take a quick look because I'm still not really satisfied. I would like to say that I get the stream done on time, but I would really like to say that I see this thing work. So we're going to do that instead. Basically what happened was I didn't fill out this to-do for the not failed case. And all I have to do to fill this out is iterate through all the cells and get their value by, oh, yeah, okay. So, we can do this in a very easy way. For uint32, x equals 0, x is less than width, plus plus x. For uint32y, y equals 0, y is less than height, plus plus y. Or what I should really be doing here is I guess I'll just do it this way. It's probably best. T is less than sample count plus plus t uint 32t t 0. We need uint 8t cell equals coefficients x plus y times width, and then what we do is if cell t break, and then what we do is we get the first pixel of that sample. So we know the sample number. We then go to uint 32t sample equals samples t data, and then we finally in the output at x plus y times width set that equal to sample 0. Uh-oh. It's time to debug it. That's right. Still not done with this stream. Just gonna keep going. Well into 4 hours. Let's just keep it going until I figure it out. Break. What's the problem here? X is what? Y is what? W samples what? Uh-oh. Sample's no good. Sample data? You don't have good sample data? How did everything else work? What is t equal to? T equals 0. What does this cell? What does this cell say? 900. There's just 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 6. 1, 2, 3, 4, 5. 1, 2. Is it like that all the way down? Looks like it's like that all the way down the way. Yeah, it might be. That's fine if it is. We'll just have to play with it, mess with it, change it up. But if that's true, why is sample data messed up? Samples. There should be 6 of these. Whoa. These are not right at all. Okay. How did all this happen? How did we get so far with the samples? What's the sample count? It's 6. You got that from the state. What's the sample width? Sample height. 1 and 2 and 2. Good. The sample array is all messed up. It's odd. Why is that not in the samples? That could easily be... I'll have to put that in the samples eventually. Okay. Plop you there. Wow, the samples array looks bad here. Interesting. Okay. Add samples. Okay, let's take a look at this. So I set the samples array. Okay, now it's got all the bad food and whatever. And I come in here and I add my first sample. So then I'm pushing a struct onto the partition. And that struct, I set a good data on. Okay, now the samples, why didn't it get any? I'm confused with you. Your data is 1C FFD0. The samples is 1C FFD0. Yet when I pushed a struct, what I got was 1C FFE0. Oh, look at that. Ain't that strange? It's still freaking out, still looking at bad food. T is 6 now, which is different. I don't think it should be possible for it to get a 6. Yeah, so these all look correct, but the fact that it got a 6 is odd. So let's look at the cells. 900 times 6 is what? So which one am I on? X equals 1, Y equals 19. Well, what is 19 times 30 plus 1? 571. Coefficients 571. 6 zeros. What do you know? Well, that's because I'm indexing this wrong, because I'm a bit slow. Okay, 410. I wrote this code wrong, because this also needs to get multiplied by the sample count. And I feel like I probably did this in other places too. So let me go find, like, where did cell 1 get set? Yeah, that needs to get multiplied by the sample count for sure's, and so does this. Coefficients. Cell coefficients, coefficients I multiplied correctly there, cell coefficients, I multiplied those correctly. So some of those were good and some of them were bad. Alright, let's take a look. Hey, hey! Coolio. So there it is. That was just generated from those samples, and it's going to generate the same thing every time because I don't have the random seeds getting picked in a good way, but there we go. Now what I want to do is play with one last thing before we call it a day, and that is I can check to make sure that it's kind of doing what I expect. You can go away. I can make sure it's kind of doing what I expect by wait a minute. I didn't accidentally edit the file view, did I? Whatever. Okay. I can make sure it's doing what I expect by altering the occurrences array, which will change the weights, basically, right? So I say, look, I want there to be more occurrences of these sort of kitty corner ones and less occurrences of everything else by a ratio of like 4 of these for each one of the other ones, for instance. Right? Now if I run it, yeah, the output is definitely different, and I see lots of spots where it looks like maybe it worked, but I also see like that is a 0, 0, 0, 0. That shouldn't be possible actually. Some of these, something is not actually working because I shouldn't be able to see a block of zeros that are 0, 0, 0, 0, or a block of ones that's 1, 1, 1, 1, because I don't have any samples of that type. So something's not working. It'll need to be debugged next time, for sure. But that did change the output, what I just did. Something's wrong though, because it doesn't quite work. Alright, thank you everybody for following along. I'll pick this project back up next Wednesday, and I'll keep using this new for-coder virtual indent stuff then. I'll probably have it almost shippable by that point. So see you guys later. Bye-bye.